Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 2 for this week. And I'll have to confess, I had to go back and do a good bit of reviewing because these are some concepts, at least the details of, that I have not dealt with in many, many years. And so it was good for me too to actually go back and review. So we're going to talk about phases, vapor pressures, relative humidity, dew points, and frost points, and who knows, maybe even some lions and tigers and bears. All right, so let's do some review here, and I'm sure that most of all of you know about this, but just for the purpose of review, we have 3 different phases of water. We have solid, liquid, and vapor, and the process of going from solid to liquid is called melting. The process of liquid to vapor is called evaporation. And if you go straight from solid to vapor, then that is called sublimation. And this actually happens with snow. Not all snow melts and turns into liquid. Some of it escapes directly into the vapor state, and we call that sublimation. Now, you go in the other direction, from vapor to liquid to solid. Vapor to liquid is called condensation. Liquid to solid, of course, is called freezing. And if you go straight from vapor to solid, we call that deposition, and that's what frost is, okay? Frost is not frozen dew. It's ice crystals that form directly from the vapor state. All right, so let's talk about something called vapor pressure here. Vapor pressure is defined as the amount of pressure exerted by water molecules, okay? Now, the saturation vapor pressure is defined as the vapor pressure when there are as many molecules returning to the liquid state as there are escaping to the vapor state. So the two are actually in equilibrium, okay? The liquid and the vapor are in equilibrium at that point. So the saturation vapor pressure with respect to water is higher than the saturation vapor pressure with respect to ice because it requires more energy to go from ice to vapor than it does from liquid to vapor. So thus, you have fewer molecules that are able to escape the ice phase and go to the vapor phase than the number of molecules going from the liquid phase to the vapor phase. Okay? So now, let's get into some definitions. Relative humidity can be defined as the ratio of vapor pressure to saturation vapor pressure. Okay? So there's the equation. Relative humidity, vapor pressure in the numerator, saturation vapor pressure in the denominator. But we already said that the saturation vapor pressure over water is greater than the saturation vapor pressure over ice. That means that if you compare those two ratios, the vapor pressure over the saturation vapor pressure with respect to ice, and this assumes the vapor pressure is the same for both, that this ratio here is going to be greater than this one here because the numerators are the same, okay? Here, the denominator is less than the denominator here, and so this ratio is going to be higher than this one here, okay? So that means for the same amount of water vapor in the air, the relative humidity with respect to ice is greater than the relative humidity with respect to water, okay? Moving on. Dew point is defined as the temperature the air needs to cool to achieve saturation with respect to water. There is something, though, called the frost point, and it is defined as the temperature the air needs to cool to achieve saturation with respect to ice. So for the same amount of water vapor, if the relative humidity is greater with respect to ice than water, that means the frost point has to be higher than the dew point. Okay, you with me? So if the temperature drops to 12 degrees Fahrenheit and the relative humidity with respect to water is 90%, the relative humidity with respect to ice is now 100%. So with respect to ice, the air is saturated. With respect to water, it's not. Now, last page. But, and it's a big but, why talk about relative humidity with respect to water when the temperature, oh, I misspelled temperature there, I'm sorry, is below freezing? Well, it turns out that both water and ice require nuclei, or particles, to condense onto or to freeze onto, okay? Ice nuclei are extremely rare, much more so than nuclei that water vapor can condense onto. And thus it is possible to have what we call supercooled water droplets all the way down to temperatures of almost 40 degrees below zero. Not quite, but almost. And this is why pilots have to be concerned with supercooled water droplets that freeze on contact with the airplane. And so the shape of the wings that helps the airplane to, maintain its altitude, if ice starts to form on those wings, then you've got serious problems because now the shape of the wings is no longer what it was before, and so the pilot has to adjust for that. So that's why there are these de-icing procedures that go on all the time to make sure that the airplanes don't encounter difficulty when they encounter these supercooled water droplets when they get up to very, very high elevations. All right, I know that was a lot, and I hope at least some of it made sense. That is the bonus weather video number 2 for this week. The daily weather update has already been posted, so we hope you check that out. Hope you have a wonderful, wonderful weekend. We will be back with you again on Monday with another daily weather update, and the next bonus weather video will be coming up next Tuesday. So that's it for now. Have a great weekend, everybody, and we'll talk to you soon. Bye-bye.